Okay, so got a worksheet. I'll show you the problems. It's pretty early worksheet for starting students with Algebra 1. I like to do I'd like to do about half the course in the first 2 or 3 days, get it in front of us so we can work with it a little bit every day. So there's typical Algebra 1 problems, some writing products, solving some simple equations, some early equations. I shouldn't call them simple, nothing simple till you learn how to do it. And some of the rules of exponents, just making sure that that stuff's in order. Then I've got more problems over here. Got some imaginaries, got some factor by grouping, some solving inequalities, absolute value inequalities, some functional notation work. All right, so just gonna do some quick stuff there, and then the last bunch of problems. How long did it take me to put these on the board? I don't have René Descartes with me, so I can't move the card around, but I can at least show you what you're looking at, and then I'll get the video started here and work through these problems. Is there anything else I want to say before that? I don't think so. Okay, so some early work, some early algebraic efforts here. All right, so I'm not going to talk a long time because I've got a commitment here in 45 minutes. So I hope I can do 45 problems and 51 problems in 45 minutes. Well, I can stretch it to an hour, but then I really got to run. All right, so this equal sign doesn't mean it's an equation. It simply means an equal sign means may be written as. If I said 2 plus 3 equals, I hope you don't think that's an equation. But 2 plus 3 may be written more simply as 5. So that's the kind of work we're doing here. Oh, this is not a good eraser. This is not a good thing. Let me check my bag real quick. While I'm doing that, let me give a shout out to Yasser. I appreciate the comments you're making, and especially what you said on the algebraic shortcuts. What can be found where. Very helpful. So thank you. All right, I guess I'm just going to have to do this quickly. So 2 times 3x is 6x. 2 times 5 is 10. Minus 4 times 2x is minus 8x. And don't forget to say minus 4 times minus 3, minus 12. So what do we get? 6x minus 8x, which is equal to minus 2x. And 10 minus a minus 12 is plus 22. So it's just some quick work here. God, I wish I had something that I could erase with, but I don't. So I'm going to have to use this. It's going to get messy. All right, so that's that problem. That's a little better right there. I'll get rid of this. If you want to do some quick multiplication, I'm not going to explain the foiling process. I'm just going to do it. X times X is you're squaring all kinds of numbers. X means something in Arabic. Something times something is something squared. Something times 5 is 5 times something. Minus 4 times something. And minus 4 times 5 is minus 20. So that calculation on the left, which is written in product form, could have been written as a sum of x squared plus x minus 20. All right, obviously I said that's a product because if you ask a typical high school student what factoring means, they don't say turn sums and differences into products. And they factor and factor and factor in Algebra 1. It would be nice if you could define what factoring is. It's turning a sum and difference into a product. Okay, the helpfulness of that is you can write multiplication, sum and difference as multiplication. It can be used as an inverse operation in a multiplication problem. A to the fourth times a to the 3, a to the fourth is a times a times a times a, that's a to the fourth, times a to the 3 means I'm multiplying times 3 more of these a's. And if I count them up, I sure see 7. So what's the rule? Addition in that case. Division. That worked race before, now it's messy. All right. A to the 8 over a squared may be written as a to the 6 times a squared divided by a squared. I think I know what a squared divided by a squared is. It's not canceled. I know we use the word cancel, but it isn't canceled. It's really the number 1. And 1 times a to the 6, the 1 does disappear. We don't need to write times 1. But sometimes that 1 doesn't disappear. Okay, so that's that one. Now I can write above it. A squared to the fifth means a squared times a squared times a squared times a squared times a squared. And I think from our first problem, we may call that a to the 10th. So is there a rule for exponents here? Yes, there is. If there's a rule for exponents, then there's also a rules for logarithms, which we'll get to in another month, after we learn some values of e to the x. 2a minus 7 squared, well, you certainly can take time. Go ahead, take time and do the FOILing. But I'm suggesting that after you get your answer, and your answer will be 4a squared minus 28a plus 49. That's what you're going to get when you FOIL that. I think you should always look at your answers and say, could I have gotten that right from here without having to write that? And the answer is a big yes. So why don't you take a look and see if you can see the pattern. Very important to see patterns in math. That's why I'm not a big fan of sequential mathematics, working on one problem per day, or just a couple that are similar. I don't think gives you a wide view of the patterns in mathematics. All right, so I just did that. Okay, there's your x plus 4 squared, and the rule is do the hardest operations first. So I'm going to do that, and I know the pattern of squaring. So x squared plus 8x plus 16. And I know I still have to multiply that by -2. And the last thing I'm going to do is add the 5. That's the easiest operation. We don't have to put the plus in front here, but I certainly could put it in the back there if addition is commutative. So what's my final answer? What could this thing have been written as? I guess I'll write it right here. Minus 2x squared. Minus times that is minus 16x. I'll do the last part in my head. Minus 2 times 16 is minus 32 plus 5 is minus 27. That means you could pick any x value you want, plug it in there, do the math. You should get the exact same answer as if you do it over here. That's what algebra is about. What can we say about the processes for all numbers? Now, I don't like the textbook method of multiplying by a reciprocal. I think I have to think about that, and I don't want to think. All I want to do is take addition, make it subtraction, take division, make it multiplication, take multiplication by 2, and give me the division. And I would prefer to see that so that I know that your thought process is correct, and I don't get hung up on unnecessary writing. So in my class, feel free to line up your equal signs and show me the inverse operation process. All right. I think I can get this done. So I don't like dividing by negatives. Let me move. I don't have a name for the chair. I have a name for my cart. The cart's named Rennie, but I don't know chair. Don't know. So I'm going to bring a minus 9x to the left. So I'm going to have to do it over here. That becomes 4x. I guess I have to do it here. So if I bring that this way, I have 4x, and I do like to line up my equal signs. Minus 17 becomes positive 17 on the other side, which is 6. And I know 6 over 4 can be reduced to 3 over 2, so I might as well do that. But in my class, feel free just to show me 6 over 4. There'll be other places to reduce fractions. Thought process is everything. Writing the equation of a line, I hope it's easy for you now. So we're going to write x minus 3 plus 1, and then I can see the change from 3 to 7. That's a whole lot easier than saying x2 minus x1. Both aren't too hard, but how do you get from 3 to 7? You go up by 4. How do you get from 1 to 6? You go up by 5, and that connects our x's and our y's. They are now connected. And if I plug the number 7 in, I should get a multiple of 4. When I plug 3 in, I get 0. I know 4 goes into 0. I drop 7 in, I get a 4. I know 4 goes into 4. Let's go up another 4. 11. I drop 11 in, I get 8. I think I could keep doing that forever. And I think I'm in the early stages of understanding my times tables. Okay. Point slope form. I wish that point slope form would change in the textbooks to adding 4 on this side. That allows me to see 3. Oh, I'm trying to do this to mx plus b. So I'd move it over anyway. All right, so minus 5/7 times x is minus 5/7 x. Minus 5 times minus 2 is positive 10. I'll write positive 10, and then I have to divide by 7. And if I'm going to add 4, if I'm going to add 4, well, I can't. These are not like divisions. I need the like division. So I hope you can see that 7 times 4 is 28/7. I hope you can make that connection. So my final answer is minus 5/7 x plus 38/7. And now I can see a product. I can see 0, 38/7. That's why that's your y-intercept. Then I can see that I go down 5 and over 7, and I got a line that has that kind of trajectory. Let's erase that. That was this problem. Next, mx plus b. I think I missed a problem, so I'll give you one that I would have said. Y equals minus 2/9 x plus 1 minus 7. All right, give me 3 coordinates. Well, if you can go from a point to an equation, I hope you can go from the equation to the point, minus 1, minus 7. From our previous discussion 5 minutes ago, that's the change in x. So I'll go up 9 from -1. I think it takes me to 8. I think it takes me to 17, and I'll go down 2 on the y side. If I put 17 in, I better get a multiple of 9. 17 plus 1 is 18. I'm feeling pretty good. Didn't make a mistake. Got to erase the board anyway. Okay, this is the first time we've seen this system of equations. I've got 2 lines that are DEC, increasing. Yeah, that's too bad. That's not the best thing to show you at this stage. Okay, x-intercept and y-intercept. Y-intercept 1/3. That is now 1/3 of a unit. I got to be real careful here. And the x is minus 1/2, which should be a little bit further in this direction. That's the first linear situation. The second one is 7/3. 7/3. If that's 1/3, 7 of them would be maybe out that far. And my y-intercept is -7. That's way down here. Wow, I don't know. I don't know if I trust doing this. I'm not going to trust that to tell me that I have a positive and a positive answer. I just don't necessarily believe that because I should have done a better job at graphing. All right, so let's just solve it. All right, so what's the easiest way to solve? You could do substitution or elimination. I'm going to eliminate the y column. I'm going to take 2x minus 3y equals -1. Because of time, I'm not going to explain this too much. But if I make this positive 3y, I can add up the columns and one of the variables disappears. So I'm going to multiply 3x minus y. 3x minus y equals 7 by -3. Minus 3 times 3x is minus 9x. Minus 3 times minus y is positive 3y. Minus 3 times 7 is minus 21. And this is minus 7x. Y's cancel. Equal 22. -22. Okay, so one of my answers is 22/7, and that's the x value. So maybe my graph wasn't too bad. I do have a positive. So I'm starting to feel better about the little sketch I made. And since I have a fraction, I'm not going to substitute. I'm going to repeat this process, but I'm going to repeat it for getting rid of the x's. So I'll multiply the top by 9 and the bottom by 2. And I'll go straight across. And because of time, I'll take some shortcuts. Minus 27y equals -9. And -18x plus 6y equals -42. Now I wrote that out, but if I was really doing this, I wouldn't even have written the x's because they cancel. So I would have cut right to the chase and just done those. And what do I get? I get minus 19y equals minus 51, which is y equals very close to 3, huh? 51/19. Okay, so a little less than 3. Okay, I like the graph I did before. Didn't know it until I did the problems out. I make more mistakes on this problem than any other because of just carelessness, trying to rush through it. A lot of times I just gotta get an answer key up. I'm teaching 3 classes and I don't have time to do things out. I just gotta go after it. Then I feel, oh, terrible because I'm making mistakes on my answer key, but gotta live with it. And I'm under time pressure here as well. So f of x equals 2x squared plus 12x minus 5. And I'm trying to find, I'll write y equals 2x squared plus 12x minus 5. Lots of ways to get this, but the easiest way to get the minimum value, and the minimum value of this parabola that is cup shape up, is to find that y value. Okay, so let's find it. Minus b over 2a gets the x. And I'll go back to notation, f of x minus b over 2a. So in that case, it's minus 12 over minus 4. 2 times 2 is positive 4, excuse me. So minus b over 2a. There, I got that. I now know that's minus 3, so I'm going to plug minus 3 into the calculation. And if I do, I'll get my minimum value. Minus 3 squared, 9 times 2, 18. That should be 36. Oh, good, it is. Minus 18 minus 5. The answer to that question is minus 23. That's the minimum y value. Every other y value is above it. That's the minimum, minus 23. So the next one's a maximum. Why is the next one a maximum? Well, let's write it. We'll keep it as f of x. Saves me a little writing, even though it's g. All right, I'll do that. I hope I don't get into time pressure. So g of x minus 3x squared minus 24x plus 7. You get good at this, you can do it in your head. So minus b over 2a. Let's do that. 24 divided by negative 6 is negative 4. I'll cut it in half. Negative 2 times negative 24, 48 plus 7. You should get a maximum y value of 55. Now you check it. I'm in trouble here in terms of time. Very similar to the last problem. Could have made a careless error there. Hope I didn't. 5x minus 2y equals 17. I've been asking you to look for patterns. So this is perpendicular to, I don't know, I didn't give you anything. So why don't we do, how about a cat mouse? No, how about dog cat? Yeah, let's do cat mouse. Cat mouse. Let's do capital letters, because I'll be doing this. Capital letters, and you can use the capital letters. Okay, there's a lot of people coming to me and go, what the heck are you thinking about? It's just symbolic conversion. Get rid of cat. If you have a cat, you can catch a mouse. How's that? C gets me M. And the perpendicular is right there to begin with. Minus 2/5. And if you put your answers next to the original, which over here is the perpendicular to this, is minus 2/5. Well, I think it's right there. I don't think I have to do any work anymore to find a perpendicular when something's written in standard form. It's useful knowledge. So there's the perpendicular that passes through cat mouse for this particular problem. And if you don't believe me, solve this equation for y and look at the original slope. And if the original slope, which I now know is 5/2, right? It's the negative reciprocal. You solve this for y correctly, you should get a slope of 5/2. Oh, and that's what I was going to talk to Yasser about. Yeah, you're going to look at implicit differentiation. And when I had 2x plus dx plus 2y dy equals 0, I suggest you find a couple of values for x squared, y squared, get some x's and y's, set it to some number, doesn't have to be 25. You know, pick another number where you have a Pythagorean triple, but I picked 25. And you can pick any number you want for x and y, and just let dx be 0.001, and you will see that ratio of change of minus x over y. I think it's really helpful to work with numbers. So I'll give that a go. Yasha's being very helpful here. I'm learning some things. Yes, I was going to say, oh, I'll save it for the next video, but it was, well, it's really this topic. There's y squared. There's x squared here. And what happens when you want that to equal 25? I don't have time to do that now. I'm going to do it in the next video. A lot of good chatter comes out of that. Okay. So now we have when a couple of fractions are equal. Bring my chair over. Okay, get a little easier to work with here. Well, let's set a couple of fractions that are equal. 1/4 equals 2/8. There are some fractions that are equal. Well, what can I see is true here? I hope you can see that 1 times 8 may be written as 2 times 4. And we call that cross products. So anytime you got a couple of fractions equal, do cross products. So 3 times x plus 4, I'm going to shortcut it here. 3 times x plus 4 is 3x plus 12. You check it out. Get the numbers. 2 times x minus 1 is 2x minus 2. And it sure looks like x is equal to negative 14. I bring the positive to this side. The positive to that side becomes a negative. And you can see that. I don't have time to sketch those right now. They're actually not Algebra 1 sketches, although we're going to cover it. So write this as a product, 7a cubed minus 21a. And I ask my students, what's it mean to write something as a product? And I don't know. If I ask what's factoring, I don't hear write it as a product, but we're factoring this. And the first rule, which we will use in future problems here, is take out what's common. And what's common? Well, I see 21 and 7 have 7 in common, and 8 of the 3 and 8 of the 1 have 8 of the 1 in common, and that's the smaller exponent. So what do I multiply 7a by to get to be 7a cubed? I need a squared, and I also need a minus 3 over here. And if you multiply those things, all right, now this could be factored further. This is actually 7a. Any difference can be written as the sum of the square roots times the difference of the square root. Not that we do this in Algebra 1, right? But it's not that hard to see. I will take a moment to talk about the difference of 2 squares. Well, there's 2 squares. I can put anything I want in there. I've got the difference of 2 squares. Let's put 25 and 16. Well, I know the square roots, 5 and 4. 25 minus 16 is 9. And so is 5 plus 4 times 5 minus 4. I get the same answer. Doesn't matter what I put in here. If I put cat in here, mouse, cat, mouse. All right, I can't tell you what cat minus mouse is, but I can express it as the square root of cat plus the square root of mouse times the square root of cat minus the square root of mouse. The middle terms cancel. Square root of cat times square root of cat gets me a cat. Square root of m times square root of m gets me an m with a minus sign. All right, just thought I'd plant a seed. The geometry of it, of course. Oh, difference of 2 squares. I remember here, I'm saying this awfully late, pausing the video and trying the problems. Yes, a plus 6 times a minus 6. And when do products become useful? If you set them to 0, negative 6 and 6 will get you a 0. So they're very helpful in solving equations, but these are not equations. I suppose when I write something over here, it's an equation, but this is really just a skill. So we took care of those. A squared minus 5a minus 66. I asked the question, is there anything common? And I say, no, there isn't. So this one, because the coefficient is 1, is the factors of 66. 1 and 66, 2 and 33. 6 and 11, bingo, 6 and 11, 5 units apart. So this could have been factored as following. Minus wins, so minus 11 plus 6. You do the foiling, you get that amount. You can check it by plugging numbers in. What's an easy number to plug in? Why don't we do 1? 1 squared is 1, minus 5, minus 66 is minus 70, I believe. Minus 70 on this side. When you put a 1 in, 1 minus 11 is minus 10. 1 plus 6 is 7, minus 70. Just a quick check that I didn't make a careless error, because a lot of times people get their signs wrong. Okay, I'm going to say factor. It's what the world says, but I'm writing this as a product. So what's your first rule? Take out what's common, which is 2. Everything's even. So 2 times a squared minus 5a minus 66. Boy, where have I seen that before? That's why I picked it, I think. I hope. you're seeing minus 11 n plus 6. And that is the product for this sum and difference. Hope I stated that correctly. Okay, so that's done. Okay, how am I on time? Doesn't matter, I'm going to keep pushing through. What's common? What's common here? I'm going to take the smaller exponents and figure out 25 and 15 have the number 5 in common. 12 and 7, I'll take the 7 out. 8 and 5, I'll take the 5 out. Now I got to get back to the first term. 5 times 5 is 25. A12, A7, I need 5 more on the A. M5 is already there. Minus 15, I need minus 3. I need A7. Oh, it's going to come in. I need M8. I got 5. I need 3 more. All right. Let's move over to the other side. I think I'm going to get there. N squared equals 12n. Now I got to solve for n. I got to find out what works. Well, my first step is to see if I can write it as a product. Because if I can write it as a product, I can see the numbers that work. What's the first rule? Take out what's common. You'll be hearing me say that the rest of the term. Do you think you can see that n could equal 0? You think you can see that n equals 12? If not, take n and make it a 0, and take the other n and make it a 0, and you do the math. 0 times negative 12. It works, so will 12. Next one. I think I'm going to try the same thing. I think I'm going to move the 12 to the other side and see if I can do it as a product. Trying to get a lot of practice with products because I've seen that people have some major gaps from their previous level of study. That's why we're doing this worksheet. And a lot of you had to sit through Zoom sessions and, not the best way to learn, but we all did our best. Numbers that multiply out to 12 that are 4 apart. I'm seeing 6 and 2, n minus 6. That's going to win out. N plus 2. Can you see the numbers that work? One number that works is 6. The other number that works is negative 2. Now we move to absolute value. And I said in a previous video, and I don't even know if I've assigned it yet, but if I simply change this to a parentheses and put a plus minus in front of this, I'm going to get 2 equations. One of them is positive. Remember, I'm going to put a plus minus here. One of them is positive 2. Of course, this is V-shape up, right? This is a V-shape up, and the first side is actually coming down. So I'll put a negative in front first, because we're going to do this as piecewise. So one of the pieces is negative 2, and n minus 4 plus 5 equals 31. I'm doing it this way because I don't want to have to think. I can solve that equation without thinking. And the other one is positive 2, n minus 4 plus 5 equals 31. We'll solve both of those in a minute. There are better shortcuts, but this is what I mean by a piecewise function, right? This absolute value V-shape could have been written as 2 pieces. And if I want to, no, I didn't write it as a piecewise. I did the equation, my fault. Too much of a hurry. The piecewise function occurs when we put the critical number in, which is 4. So when x is less than 4, I'm on the decreasing side. And when x is greater than or equal to 4, I'm on the increase, and we'll keep talking about that all term long. If I want to know when it equals 31, since I've already written this, I'll go 31 here. I'll go this one up. Subtract 5, 26. Divide by negative 2, negative 13. I'll show you why there's a sign change there. Add 4 gets me negative 9. I'm going to keep that right there. Then we'll do this one going down. Let's set it equal to 31. Well, that's 26. Here's my sign change, positive 13. I'll explain that at a later date. Add 4, 17. Minus 9 plus 17 is 8. 8 divided by 2 is 4, which is the critical number. I didn't make a mistake. So now I have 2 critical numbers, which I just erased. I think I said minus 9 and 17. And if I want to know what I'm greater than 31, for the, there's shorter ways to do this, but right now I'm going to pick a number bigger than 17. I'm going to put 1,000,000 in here. And I get truth. They alternate. Because of time, that's all I'm going to say at this point. They alternate. All right. And interval notation, you're used to doing this. Add negative 9. Well, it goes to negative infinity. We could express the same thing this way. Oh, union, you would have to write the word or. On this side, it's 17 to positive infinity. Okay, which could have been written this way, 17 to positive. This is called interval notation. And if I had put or equal to, then these get colored in. Where am I? I didn't draw that one. That one gets colored in, and we change the parentheses to a bracket. And that's enough for today for that. We can learn that before May, 15th, the end of the term. If we work with it every day. I don't think I have to say more now. Don't be in a hurry to learn everything on the spot. Just do it repetitively. It served me well, I can tell you that. My brain changed when I started doing this. All right. Thank God it changed. I was crazy enough as it was already. All right, number 14 was a sketch. So I forgot to write a number 14. So what did I have over here? I even forgot this number. I think it was a 5. So we plug in cup shape up because it's cup shape up. You can see how many quadratics I do. V shape up, 4, 5. I hope you see the pattern there from everything else we're doing. Where's the y-intercept? Left or right of 4? Left side. 0 is to the left of 4. And if I put a 0 in, I get 8 plus 5, 13. And I think you can see that the slope on the left, 13 to 5 is down 8, 0 to 4 is over 4. Hope you can see why I wrote the slope on this side is negative 2. Now, just planting some seeds here. We're going to be practicing this stuff daily in class. You're already getting good at the first things we're practicing. All right, so I hope that you remember from your previous levels of study all about whether or not signs, greater than changes or not. I avoid that by never dividing by a negative. I'll talk more about it later. So I bring the 6x over, that gives me 8x. I bring the 8 to that side, and I don't have to change. So x is bigger than 1. If I want this to be a true statement, I better pick numbers bigger than 1. I'm going to keep going because I don't know how much time I have left. All right, so 2 times negative 3, that gives me 10a squared times a to the minus 6 over 50a to the 6th. What we're going to be learning is you can take negative exponents and put them in the denominator as positives. I could have also done something else, but I just want to highlight that right now. I'll show you why in class. Actually, I've already showed you once, but going to have to show you more. So 10 goes into 50. I know 5 times. I know a squared is going to disappear in this problem, but I'm going to get a 1. The 1 does not disappear. So I have 12 a's in the denominator as factors, 2 in the numerator. There are 10 more here, right? 6 and 6 make 12. Subtracting or seeing that there are 10 more, right? a to the 12th is a squared times a to the 10. And I hope you can see the division getting us a 1. And it doesn't disappear because the 10 gave us a 5. Okay, I'm running out of breath, but I'm just going to fly here, hope that somebody gets a little practice. Remember, you're pausing the video. All right, I hope my class knows what that 2 means now. We've done it for a couple of weeks. I'm going to take the square root of 25, which is 5. I'm going to cube it, which is 125. And because I got a negative, I'm going to make this flip, and I get 1 over 125. I wish I had more time for this problem right now because it's the first time we've done it. X minus 3 is actually a square root function that grows slowly to the right and starts at 3. X minus 5 goes up 1 to 1, right? 1 to 1. So I can see this is only going to have one answer. So what do? Inverse operations. I'm going to square the left. That gets me x minus 3. If I square the right, that's why binomial squaring is so important. Can't tell you how long it takes for students to learn how to do that and not say x squared plus 25 or x squared minus 25. There's a middle term here. All right, now I set it to 0, just like we were doing those other problems, and I hope I can factor this. And because I made this problem up, I'm guessing I can. Minus 11x, add 3, 28. Oh, 4 and 7. So 0 equals x plus 4, x minus x, both negative. Minus 4, x minus 7. And I know that 7 is the only number that's going to work because the other answer was fictitious. Right, there's the x equals 4. Here's the x equals 7 over here. Enough said. Pause the video, look at it again. I'm really pressured for time now. I can feel it. So I'm just gonna fly through. So how do we do a problem like this? Get rid of what's troublesome, the denominators. What gets rid of division? Multiplication. What gets rid of 2x, 3, and 6? 6x. Each of these terms goes into 6x, then I'll multiply. The two x's cancel, I get the number 3, that's a 15. The 3 makes it 2x times minus 7, minus 14x. The 6 goes in x times, equals 7x. Now I add that to that side, 21x, 15. I could divide by 3 right now, 7x. If I wanted to do that, that gets me 5/7. Enough said. All right, we're just going to practice our factoring skills. What is a way that I could write this as a product? Well, 3x times x certainly gets me that. And whatever I pick here is 3 times bigger. So I'm just going to get it in my head here. What do I got? 15 and 4. So I want a 5, which gets me 15, and I want a 4. There's my multiplication. I want a negative 11. So I want that to be negative, that to be positive. That's just from experience. How do you get experience? You do hundreds of problems. Which is why we're doing 50 a day, and your final exam is going to have 120 problems on it. All right. So can I see this? I hope so, because my computer is at the edge of the desk. All right. 8 to the 19th may also be written as 8i squared. 9 times gets me to 18. 1 more gets me to 19. I know that my eraser is here. I know that I squared is negative 1. I know negative 1 times negative 1 times negative 1, 9 times is a negative. So my answer is minus 8i. And with practice, you can do those in your head pretty quickly and easily, provided we get enough practice, and we will. 11, square root of 11 times the square root of 33 happens to be the square root of 11 times the square root of 11 times the square root of 3. By definition, I know that becomes the number 11. And I know what that is as a decimal approximately. Do you? Well, I keep making it happen by saying the square root of 3. I want you to memorize it. How many of you have done so? Usually not many, but 1.73 is what we're going to be using. Factor by grouping. I've not done any factor by grouping. It's the first one you've seen. All right, and we won't do a lot of it. What do these two terms have in common? 3a. 3a times what? 7 gets me the first term. C gets me the second. Without looking, I'm betting 7 and C are common, because it's a textbook problem. Oh, I can take out the B's, and it's positive. Oh, I have 2 things times 7 plus C. Can you see them? Yes, 3a and b are being multiplied times 7 plus c. Okay? Time restrictions. Do not allow me to say anything else at this point. All right, f of x, g of x. What's f of 5? I think I better plug in 5 to the f calculation, not the g. 5 squared is 25 plus 10 is 35. That's what that was. G of 4/7. Why are we doing that? A lot of students, because of COVID, poor elementary school education, don't know how to do that. They can learn pretty easily. What's another way of writing 2? Well, first off, I need things over 7. Well, that's over 1. How did I make it 7? I made it 7 times bigger. If I do that to the denominator, I better do it to the numerator. What's 4/7 minus 14/7? I can tell you how many sevenths you have. Minus 10. Okay, and we're practicing that every day, so we get good at it. Okay, what's f of g of x? I don't know, because I just erased everything. What's g of x equals 10? I don't know, I just erased everything. I'll make a new g of x. G of x equals x plus 2. What is g of x? Equals 10. Well, g of x may be written as x plus 2. So why don't I erase g of x and write x plus 2 and solve that equation? Enough said. Last problems over here. Whoa, 10 problems, 11 problems. Can I get it done? Oh, I hope so. Got my trusty chair. All right, last problem. Distance from 4/7 to 9/2. I hope you can see 4 to 9 is a horizontal change of 5, and 7 to 12 is also a horizontal change of 5. So I know for my trig it's 5√2. because I got 45-degree angles. So we'll be doing that the second half of the term for right triangles. But you're probably squaring 25. You're probably squaring 25, which makes this the square root of 50. And I hope that's something we're working on. The square root of 50 is equal to the square root of 25 times the square root of 2, which is 5 root 2. And that's another one I've asked you to memorize, root 2. So you can give me the approximate decimal, which is 5 times 1, 5, 5 times 4, 0. I better do it out better than that. At this stage, I start to make real careless errors. You do 5 times 1.41. Yeah, I think I was on the right track. Uh-oh, she's ending class. So now I have midpoint, 8, negative 15, 32, 7. I better open the door so that if she comes looking for me, she can find me. All right, so my wife's teaching a yoga class. Here we go. Midpoint, well, what numbers between 8 and 32? Add them up, 40, divide by 2, 20. What numbers between minus 15 and 7? Add them up, negative 8, cut in half, negative 4. That's the midpoint between those two. All right, how do we do this square root problem? We write the square root of 18 as the square root of 9 times 2, because that's a perfect square. Y to the 6 times y, because y to the 6 is a perfect square. It's y to the 3 times y to the 3. So I can take 3 out. I can take y to the 3 out. Boom, boom. What can't I simplify? 2y. Okay, so now I can erase that one. 7 root 21. Okay, well, we already did a problem like that. 7 times root 21, I hope you can see, is 7 root 3 from the previous work we did. Squaring binomials. I hope you can square a binomial quickly. Square the first term, 25a squared. Double the product. 5 doubled is 10. Do not change the a and the y to the 5. FOIL it. You'll find out why. Like terms. Y to the 5 squared, y to the 10, and you're done. What's the number? Do this one in your head. 64 minus 49 is 15, so x is the square root of 15. Log base 2 of 1/8, I hope you know, is negative 3, right? Because you got to cube 2 to get 8, and you got to flip it. So we got those. I'm going to let you do 48 on your own. Factor all 4 expressions, do some cancellation, and you'll be able to do that one. We will do the bingo, bango, bongo problem, so we'll do that one in class. How do we do bingo, bango, bongo for, I don't even think you can see these. Yeah, you can still see. So we have 2 over x plus 3 minus 4 over x minus 5. I better shut this. It sounds like they're having a quiet moment in there. I think they're having a quiet moment in the other room. Oh boy, they're listening to this. God help me. Parentheses minus parentheses over parentheses. You don't have to do any of these parentheses except really that. 2 times x minus 5 is 2x minus 10. X plus 3 times 4 is 4x plus 12. Why am I stressing this parentheses? Because I have to subtract both terms, and people always butcher that. So x plus 3 times x, actually, in this case, this is a little different. I don't like to multiply those out because I never know if one of these is a factor in the numerator, depending upon textbook problems. But right now, I'm simply going to say 2x minus 4x is minus 2x. Minus 10 minus 12 is minus 22. I see x plus 11 as a factor. That's not that. So I'll multiply it out. X squared minus 2x minus 15, just for practice. Okay, 2 more problems. Oh boy, 2 more problems. I'm going to get it done. I'm going to get it done. I've got 3 root 45 and minus 2 root 20. I'm seeing a 9 there. 9 root 5. I'm seeing a 4 over here. Root 4 root 5. Okay, 3 times the square root of 9 is 9. Because the square root of 9 is 3. 9 root 5. Square root of 4 is 2. So that's minus 4 root 5. And let's let x equal root 5 for a moment. That would give me 9x minus 4x. I hope you know what to do with that. Let's get rid of that. Call it square root of 5 again. 9 minus 4, 5 root 5. I haven't asked you to memorize root 5. If we didn't have calculators and computers, I would. Last problem. Last problem. I don't even want to bend over here. 2x to the 4y squared over x 6y negative 4. And I am negative 3. I'll do this last. I got positive exponents. I'm going to move this negative upstairs as a positive. Y squared y4 is y to the 6. X4, x6, x squared in the denominator. I'm going to flip it. X squared 2y to the 6th. And now I have to cube it. Final answer, x to the 6th. I have to cube the number 2, 8. I have to cube y to the 6th, y to the 18th. And I hope we got a little whirlwind of early algebra practice. All right. Put this over here, and then I'll sneak outside and see if I destroyed the quietude of the yoga session. I hope I didn't. It's quiet. I can't even find my cursor. There it is. Hang on. Come on. Ta-ta.